We'll start in 1 minute. Today we're going to cover polar coordinates in section 10.3, and then after that we'll go over the test 3 review sheet over sections 9.3, 9.4, 9.5, 10.1, 10.2, and 10.3. And test 3 is on Monday at our regular time from 11 a.m. to 11:50 a.m. In section 10.3, the topic is polar coordinates. A polar coordinate system has a fixed point, capital O, called the pole, and a polar axis, which is a ray whose endpoint is at the pole. So it only has one endpoint. The polar coordinate system in the xy plane has its pole, capital O, at the origin. Capital O represents the word origin, but the origin in the xy plane is the point 0, 0, and its polar axis is the positive x-axis with its endpoint at 0, 0. Every point Q in the xy plane is defined in polar coordinates by an ordered pair r theta, where r is the directed distance from the pole to the point, and theta is the directed angle from the polar axis to the ray OQ. So to draw a picture of that sort of thing in the xy plane, if we just pick a point, call it Q, with x and y coordinates. Well, if we draw a line segment from the origin to the point, then this has a length, and we'll say that this length is r. And from the polar axis, the positive x-axis is the polar axis, the angle to this line segment is theta. And in this picture, r is greater than 0 and theta is greater than 0. So theta is greater than 0 if we move counterclockwise. And we'll talk more about whether r is positive or negative. But in this picture, r is depicted as positive, and so the r theta point is also the point Q. Okay, more about r. If r is greater than 0, then the point Q is located r units from the pole in the direction of theta. So that's what this graph represents. The point Q is located r units from the pole, or the origin, in the direction of theta. But if r is less than 0 or negative, then the point Q is located the absolute value of r units from the pole in the direction theta plus pi, which is the direction opposite to theta. So we'll draw another picture. So suppose theta is this angle. So in this picture, theta is still positive. But if we want r to be negative or less than 0, then we go in the opposite direction, and the length from, or the distance from the origin to this point is the absolute value of r. And so this point is represented by r theta, where theta is marked off in the first quadrant in this picture, but if r is negative, then the point in the plane is in the opposite direction. So we'll see some examples of that in just a couple of minutes. If r is 0, then the point Q is the pole. So the distance from the point 0, 0 to the point Q is 0, so that means it's just the origin. Okay, as usual, if the directed angle theta is greater than 0, it is measured counterclockwise. And if theta is less than 0, it is measured clockwise. So before doing the examples, we can draw one more picture. So if we have theta less than 0, then that's measured counterclockwise. If in this picture we say that r is greater than 0, then the distance from this point, from the origin to that point, is r, and the point is represented by r theta. Okay, let's do some examples. Okay, plot the points. We'll start with this left one. Plot this point whose polar coordinates are given. The angle is 5 pi over 6. So if we move counterclockwise 5 pi over 6, that's about right there. 5 pi over 6. And then we measure out 3 units. So I'll just make 3 tick marks to represent the 3 units. So the length of this line segment from the origin to the point is 3. And the coordinates of this point in polar coordinates is 5 pi over 6. Okay, in the next example, this time we have a negative angle, negative pi over 4. So we move clockwise pi over 4 units. So there's negative pi over 4. And the value of r is 5. So if the length of this is 5, then this point is represented by the polar coordinates, 5, negative pi over 4. So note, I'll point out something. If we would rather have a positive angle and move counterclockwise, then that angle would be, what would it be? It would be 7 pi over 4. And so we can represent the same point by writing 5 comma 7 pi over 4. More about that in a few minutes. Okay, so here's an ordered pair in polar coordinates. The value of r is -4, and the angle is pi over 3. So we'll plot this point. So pi over 3, or 60 degrees, is about like this. So here's our angle, pi over 3. But since the value of r is negative, we move in the opposite direction 4 units until the length of that distance from the origin to that point is 4. Okay, if you don't like negative r values, you don't have to have them. We can assign, for this same point that's in the third quadrant, we can measure this angle. So this angle is pi plus pi over 3, or 4 pi over 3. And we can represent this point with the polar coordinates +4 for r and 4 pi over 3 for the angle. Either way is acceptable. Hey, another example. The polar coordinates are r equals 2 and theta equals 3 pi. So in the xy plane, 3 pi, well, that's 1.5 revolutions counterclockwise, so 3 pi. And then in that direction, we measure off 2 units. So the length of that is 2. So this point has polar coordinates 2, 3 pi. Well, an angle of 3 pi is excessive. So if you would rather just do 1/2 of a revolution, then we can also represent this point in polar coordinates by 2 comma pi instead of 2 comma 3 pi. Okay, in the next part, we'll talk a little bit more about what I've already mentioned in those 3 examples. There are multiple ways to represent a point using polar coordinates. Okay, so an ordered pair xy in a rectangular coordinate system is uniquely determined, meaning that there's only one way to do it. But as we have already seen, this is not the case with polar coordinates. And here's an example. We have the same point represented in polar coordinates in 4 different ways. But there are infinitely many ways to do it. Here are just 4 out of the infinitely many ways to do it. But you don't need to make it more complicated than is necessary. If you want to plot that point, just pick the one that's easiest to plot. It looks like this first one, 2 pi over 4, is the easiest. So pi over 4 counterclockwise, pi over 4 units. And then measure off 2 units from the origin to the point. Okay, now we'll discuss how we change from or convert from polar coordinates to rectangular coordinates. And then after that, we'll do it the other way around. How do we convert from rectangular coordinates to polar coordinates? All right, well, let's draw a picture. Suppose in the xy plane we have a point given in polar coordinates. So r is given to be the length from the directed distance from the origin to the point, and theta is the angle. Well, if we construct a right triangle, and if the length of this horizontal side is just the x value, or the x coordinate of that point, and the distance or the length of the vertical side is y, so if this point is in rectangular coordinates, the coordinates are x comma y in parentheses. Hey, but we know right triangle trigonometry. We know that sine of theta is equal to the length of the opposite side of the right triangle divided by the hypotenuse. So in this picture, sine of theta is y divided by r, which means y is equal to r times sine of theta. And cosine of theta, that's equal to the length of the adjacent side divided by the hypotenuse. So this is x divided by r. So x is r sine of theta. So that's how we find the rectangular coordinates. If we have r and theta, then our x, y coordinates, the x coordinate is r cosine of theta, and the y coordinate is r sine of theta. So this is just a step beyond what we learned about the unit circle when we defined the trigonometric functions by using the unit circle. In the unit circle, the value of r is 1, but in polar coordinates, we allow r to be any value, any real number. Okay, now the other way around. Given a point Q in rectangular coordinates, x, y, show how to convert it to polar coordinates. Well, let's borrow this right triangle up here again. This right triangle, the hypotenuse is length r. The length of the horizontal side is x, and the length of the vertical side is y. So using the Pythagorean theorem, we write the length of the hypotenuse squared is equal to x squared plus y squared. Okay, so we're going to use that down here. If we have a point in rectangular coordinates, x comma y, then the way that we find r is we take the square root of x squared plus y squared. Okay, then what about theta? Well, let's go up here to this right triangle again and observe that tangent of theta is y over x. So down here, we make use of that. Tangent of theta equals y over x. We do have to be careful, though, when we're looking for theta, because the inverse tangent of y over x, remember what the range of inverse tangent is. The range of inverse tangent is between negative pi over 2 and pi over 2. So if theta itself is in, say, the second quadrant, then the inverse tangent of y over x will give us a value that's in the first quadrant, and then we have to find the angle theta in the second quadrant by taking pi and subtracting the inverse tangent of y over x so that we're in the second quadrant. So if the point that we're working with is in the first quadrant, then the inverse tangent of y over x will be theta. And also, if the point is in the fourth quadrant, then the inverse tangent will give us theta in the fourth quadrant. But, so I'll just make a note, if theta is in the second or third quadrant, then theta is not equal to the inverse tangent. So I'll just say theta is not equal to inverse tangent of y over x, but we can use a reference angle to help us get the correct theta value. So we'll take those case by case. Okay, this one, convert the points in polar coordinates to rectangular coordinates. So the value of r is 4, and theta is 3 pi over 2. So x, I'll just remind you, x is r times cosine of theta. Y is r times sine of theta. So x is 4 times cosine of 3 pi over 2. And y is 4 times the sine of 3 pi over 2. Cosine of 3 pi over 2 is 0, so the x-coordinate is 0. Sine of 3 pi over 2 is -1, so the y-coordinate is -4. So the xy coordinates are 0 and -4 for x and y. You could see that graphically. 3 pi over 2, that's equivalent to 270 degrees. So this will put you, the angle terminates on the negative y-axis. And so on the negative y-axis, the x-coordinate is 0 and the y-coordinate is negative. Okay, the next one, this is in rectangular coordinates. Sorry, it's in polar coordinates. We want to convert it to rectangular coordinates. And then afterwards, we'll see if it makes sense. Okay, so we know that x equals r times cosine of theta. So x equals -2 times cosine of -5 pi over 6. Cosine of -5 pi over 6, I'll write a reminder for you up here. Cosine is an even function, so cosine of -5 pi over 6 is equal to cosine of +5 pi over 6. And cosine of 5 pi over 6 is the square root of 3 over 2. Okay, so the x-coordinate is -2 times the square root of 3 over 2, or negative square root of 3. And then the y-coordinate is -2 times sine of -5 pi over 6. So sine of -5 pi over 6 I made a mistake up here. 5 pi over 6 is in the second quadrant, and cosine is negative in the second quadrant. So this should be negative, and -2 times negative square root of 3 over 2 is positive square root of 3. Okay, so the x-coordinate is the square root of positive square root of 3. Okay, so on this one, y is -2 times sine of -5 pi over 6. Sine is an odd function, so the sine of -5 pi over 6 is equal to the negative of sine of 5 pi over 6. So -2 times -1 times positive 1/2 is positive 1. Okay, so let's see if we can make sense out of this. Let's first plot this point. So -5 pi over 6 is about right here. -5 pi over 6. But since the r value is -2, it means we move in the opposite direction 2 units. So let's mark those 2 units off. And this angle right here is pi over 6. So our point should be in the first quadrant. And this work shows that it is in the first quadrant. The x-coordinate is the square root of 3, and the y-coordinate is positive 1. So yeah, I think it checks out. Pretty sure it checks out now. Okay, now let's convert rectangular coordinates to polar coordinates. Okay, so this point, negative 3, 3, is in the second quadrant. Let's just observe that first. Negative 3, 3. It's in the second quadrant. Okay, so the x value is negative 3, and the y value is 3. Remember that r squared is x squared plus y squared, so negative 3 squared plus 3 squared, or positive 18. So the r value we want is 3 times the square root of 2 when we take the square root of 18. Okay, so this, we want to find this angle. If we want the positive angle, we'll call that theta. Tangent of theta is equal to y over x, 3 over negative 3, or negative 1. Okay, but the inverse tangent of negative 1 that's negative pi over 4. So that's over here. So we can get theta if we add pi to negative pi over 4. Right? Theta and negative pi over 4 form a straight line. And so theta is just negative pi over 4 plus pi or 3 pi over 4. Okay, so I'll just circle what r is. R is 3 times the square root of 2, and theta is 3 pi over 4. And we can verify just by doing more arithmetic if you want, that those are the right polar coordinates. Okay, at this point, negative 2 for x and negative 2 times the square root of 3 for y. This is in the third quadrant. So you can visualize that. It's in the third quadrant. R squared is equal to x squared plus y squared. So negative 2 squared is 4, and negative 2 times the square root of 3 squared is 12. So r squared is 16. And so the value of r is 4. Okay, the tangent of theta is the y-coordinate, negative 2 times the square root of 3 over negative 2. which is the square root of 3. Okay, but the inverse tangent of the square root of 3 is in the first quadrant, and we know that that's pi over 6. I did that wrong. It's pi over 3, right? Because tangent is sine over cosine, and sine of pi over 3 is the square root of 3 over 2 divided by cosine of pi over 3, which is 1/2. Yeah, so the inverse tangent of the square root of 3 is pi over 3. Okay, but that's in the first quadrant, and so the theta that we want is in the third quadrant. So all we have to do is add pi to pi over 3. So theta is pi plus pi over 3, which is 4 pi over 3. Okay, so the value of r in polar coordinates is 4, and the value of theta is 4 pi over 3. Okay, the next one, x is 2, and y is -3, so r squared is 2 squared plus the number -3 squared, or 4 plus 9, or 13, and so r is the square root of 13. The given point in rectangular coordinates is in the fourth quadrant, and so the angle that we want, tangent of theta, is equal to -3 over 2. Well, since it's in the fourth quadrant, it turns out that this time the theta that we want is the inverse tangent of -3/2. It will just be a negative angle, but that's okay. And so the r theta coordinates are the square root of 13 for r and inverse tangent of -3 over 2. If you don't like the negative angle, you could just add 2 pi to it. That will give you a positive angle. Okay. We'll do some conversions of equations, convert the equations from rectangular to polar coordinates. So 2x plus y equals 6. Well, this isn't too bad. X is r times cosine theta. Y is r times sine theta. So replace x with r cosine theta, we get 2 times r times cosine theta, plus y, which is r times sine theta, equals 6. And we'll factor r out of each term on the left-hand side, so we get r times 2 cosine of theta plus sine theta equals 6. And then we'll solve for r. So this is often what we do when we write equations in polar coordinates. If possible, we just write r equals something in terms of sine and cosine. So if we divide both sides of this equation by 2 times cosine of theta plus sine of theta, then we're done converting the equation from rectangular form or rectangular coordinates to polar coordinates. Okay, so this equation in rectangular form, we recognize this as a straight line. The graph is a straight line in the xy plane. The slope is -2 and the y-intercept is 0, 6. So it's not quite as obvious that r equals 6 over 2 cosine theta plus sine theta is a straight line. Okay, convert this equation to rectangular or to polar coordinates. You'll recognize this. This is the standard form of an equation for a circle. So this is just a circle. The center is the ordered pair 0 for x and 2, 0 for x and 2 for y, and the radius is the square root of 4 or 2. Okay, but we're going to convert this to rectangular form. So we'll borrow from what we wrote up here. X is r cosine theta, y is r sine theta. So x squared becomes r cosine theta squared, and then plus, inside the parentheses, we have r sine theta minus 2, quantity squared equals 4. So we will expand these. When we square r cosine theta, we get r squared times cosine of theta squared. And when we square the quantity r times sine of theta minus 2, we get r squared times sine of theta squared minus a total of 4r times sine of theta. And then -2 times -2 is plus 4. And then equals 4. Okay, so we'll subtract 4 from both sides. So the right-hand side will become 0. And we'll factor r squared out of those two terms. So r squared times the quantity cosine squared theta plus sine of theta squared minus 4r sine of theta equals 0. Cosine of theta squared plus sine of theta squared is 1. So we get r squared minus 4r sine of theta equals 0. And there's more that we can simplify. Now we'll add 4r sine theta to both sides. So we get r squared equals 4r sine theta. And finally, we divide both sides by r. So r is 4 times sine of theta. So, believe it or not, r equals 4 times sine of theta when graphed is a circle. Okay, let's do it the other way around. Let's convert some equations that are in polar form and we'll convert them to rectangular coordinates. So r equals 2. One way to think about this before we convert it to rectangular coordinates is that since theta is missing, theta is allowed to assume all values. So if theta ranges from 0 to 2 pi, and the radius is always 2, if the r value is always 2, then what you get is a circle centered at 0, 0 with radius 2. Okay, but when we convert this to rectangular coordinates, Well, we start by multiplying both sides by r. Well, actually, what I want to do is I just want to square both sides. So r squared equals 2 squared. R squared equals 4. But then remember that r squared is x squared plus y squared equals 4. That's one of the things, one of the quantities that we want to remember is that r squared equals x squared plus y squared. And we're done. X squared plus y squared is the standard form of a circle centered at 0, 0, whose radius is 2. So this is a circle. Hey, the next one, what do we do with this? Theta equals pi over 3. We want to come up with an equation that's in rectangular coordinates involving x and y. Well, in this equation, theta is given to be pi over 3. The r value, or the r variable is not present. We don't see it. So what that means is, as long as theta is pi over 3, r can be any value. So this should be, the graph of this should be a straight line, because the r values can be positive and negative as long as the angle is pi over 3. Okay, so that might convince you that the graph is a straight line, but how do we convert it to rectangular coordinates? Well, this time we're going to use the fact that tangent of theta is equal to x divided by y. But in particular, since theta is pi over 3, we have tangent of pi over 3 equals, I did that wrong. Boy, I'm really messing up. Tangent of theta is y over x. Sorry about that. So in this case, tangent of pi over 3 is y over x. But we know what the tangent of pi over 3 is. So that's sine of pi over 3 over cosine of pi over 3. So that's tangent of pi over 3 is the square root of 3. So the square root of 3 equals y over x. And so y equals the square root of 3 times x. So if you have a angle of pi over 3, and if r is allowed to be any number, then you just get a straight line. And we know that this is a straight line that passes through the origin. So those two lines are equivalent. Okay, the next one, r equals 4 times cosecant of x, or cosecant of theta. So cosecant of theta is 1 over sine of theta. So we can rewrite this as r equals 4 over sine of theta. And then if we remember that y is equal to r sine of theta, that means that sine of theta is y over r. So y over r is sine of theta. And then if we replace sine of theta with y over r, So on the right-hand side, 4 divided by y over r is equivalent to 4 over 1 times the reciprocal of y over r, or r over y. Okay, so r is equal to 4r over y. Let's multiply both sides by y, so we get y equals 4r. And then lastly, divide both sides by r, we get y equals 4. So the graph of y equals 4 in the xy plane is a horizontal line with a y-intercept at 0, 4. So is the graph of r equals 4 times cosecant of theta. It's a horizontal line. Okay, this one, r equals negative 8 cosine theta. So let's remember that x is r times cosine theta. So x over r is cosine theta. So we will replace cosine of theta with x over r. So we get r equals negative 8x over r. Then multiply both sides by r, we get r squared equals negative 8x. Then we'll replace r squared with x squared plus y squared. So we get x squared plus y squared equals negative 8x. What we have is an equation of a circle in rectangular coordinates. I'll just take this a step further. If we add 8x to both sides, we have x squared plus 8x plus y squared equals 0. This is an equation of a circle. It's not in standard form. We can get it into standard form if we first add 16 to both sides. And then x squared plus 8x plus 16 can be written as the quantity x plus 4 squared plus y squared equals 16. So this is the standard equation for that circle. Okay, there is, I have one more page from section 10.3 on graphing a couple of equations that are in polar coordinates. However, those are extracurricular. I'm not going to test you on graphing. So let's just go ahead and start with the test 3 review sheet. Okay, so there's a typo. This should be test 3 review sheet. Under section 9.3, number 1, use double angle formulas to evaluate. So I'll just remind you of the double angle formulas for practice. Sine of 2x is equal to 2 times sine of x times cosine of x. So if we use this formula in reverse, this is equal to sine of 2 times 15 degrees, or sine of 30 degrees. And sine of 30 degrees is 1/2. We know that. Okay, the next one, cosine of 22.5 degrees squared minus sine of 22.5 degrees squared. Well, for this one, the double angle formula, cosine of 2x is equal to cosine of x squared minus sine of x squared. So if we evaluate this, this is cosine of 2 times 22.5 degrees, or the cosine of 45 degrees. And the cosine of 45 degrees is the square root of 2 over 2. Okay, then the double angle formula for tangent. So tangent of 2x is 2 times tangent of x divided by 1 minus tangent of x squared. So we do that in reverse. So if x is 75, then 75 degrees, then 2x is 150. So this is just the tangent of 2 times 75 degrees, or 150 degrees. Well, 150 degrees is in the second quadrant, and tangent is negative in the second quadrant. If you want to think of this as sine of 150 degrees over cosine of 150 degrees, you can. In the second quadrant, sine of 150 degrees is positive 1/2, and cosine of 150 is negative square root of 3 over 2. And so this will become negative 1 over the square root of 3. Okay, on number 2, use reduction formulas to evaluate. So the reduction formula for sine squared, if we have sine of x squared, we can write that as 1 minus cosine of 2x divided by 2. So this becomes sine of 165 degrees squared. That's 1 minus cosine of 2 times 165 degrees, which is 330 degrees, over 2. 330 degrees, that's in the fourth quadrant. Cosine is positive, so cosine of 330 degrees is equal to cosine of 30 degrees, which is the square root of 3 over 2. So we can write this as 1 minus the square root of 3 over 2 over 2. And if you have this on a test, that's an okay answer, but you could write it as 2 minus the square root of 3 over 4 if you simplify further. Okay, the reduction formula for cosine squared. So cosine of x squared is 1 plus cosine of 2x divided by 2. So for this one, we can write cosine of 105 degrees squared as 1 plus cosine of 2 times 105 degrees, which is 210 degrees, divided by 2. 210 degrees is in the third quadrant. Cosine is negative in the third quadrant. So cosine of 210 degrees is the negative of cosine of 30 degrees. So this is 1 minus the square root of 3 over 2 over 2. This turns out to be the same number as the previous example. Okay, the reduction formula for tangent squared. So tangent of x squared, that's just 1 minus cosine of 2x divided by 1 plus cosine of 2x. So we can write this as 1 minus cosine of 135 degrees divided by 1 plus cosine of 135 degrees. So 135 degrees is in the second quadrant. The reference angle is 45 degrees. But cosine is negative in the second quadrant. So I'll finish the answer up here. I'll write 1 minus negative square root of 2 over 2. And then in the denominator, 1 plus negative square root of 2 over 2. We'll simplify it a little bit more and call it good. So in the numerator, let's just write 1 plus the square root of 2 over 2 and divided by 1 minus the square root of 2 over 2. So on a test, this is an okay answer if you want to leave it like that. Okay, the next part, use half angle formulas. So the half angle formula for sine, sine of alpha over 2, that's equal to positive or negative square root of 1 minus cosine of alpha over 2. You can see that this half angle formula is derived from this reduction formula. If we just replace x with alpha over 2, then 2x becomes alpha. And then when you take the square root of both sides, you get positive and negative. Okay, so if alpha over 2 is 15 degrees, well, we know sine of 15 is positive, so this will be the positive square root of 1 minus cosine of 30 degrees over 2. And the cosine of 30 is the square root of 3 over 2. So I'll just write one more step, the square root of 1 minus the square root of 3 over 2, all over 2. So just leave it like that. Okay, the half angle formula for cosine of alpha over 2 is positive and negative square root of 1 plus cosine of alpha over 2. Cosine of 75 degrees is positive because 75 degrees is in the first quadrant. So the alpha over 2 is 75, so alpha will be 150. So this will be the positive square root of 1 plus cosine of 150 degrees over 2. Cosine of 150 degrees is negative square root of 3 over 2. So this answer will be exactly the same as this one over here for sine of 15 degrees. And we know that for another reason. Remember the co-function identities from earlier? So sine of theta is equal to cosine of pi over 2 minus theta. So that's what we have going on here. That's why they're the same. Hey, the half angle formula for tangent. Well, this turns out to be tangent of alpha over 2. Turns out to be 1 minus cosine of alpha divided by sine of alpha without plus or minus. So we can write tangent of 165 as 1 minus cosine of 330 degrees divided by sine of 330 degrees. Because the 165 is the alpha over 2, so alpha is twice as big. Okay, I'll leave the rest of that for you to do. We've seen those angles before. Those are angles who have special angles for reference angles. Okay, next page. From section 9.4, use product to sum formulas to evaluate. So this first one, cosine of 75 degrees times cosine of 15 degrees. Well, I don't remember those formulas, so I have to derive them every time I need them. So in one of the formulas where we see cosine of one angle times cosine of another angle involves cosine of alpha minus beta. So this is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And then the other one, cosine of alpha plus beta. I get cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And if I want something of this form, cosine of one angle times cosine of another, I can get that if I add these two equations. So on the left-hand side, we get cosine of alpha minus beta plus cosine of alpha plus beta. And when we add the right-hand sides, these terms on the right cancel out, and we get 2 times cosine of alpha times cosine of beta. So the formula I want is cosine of alpha times cosine of beta equals 1/2 times cosine of alpha minus beta plus cosine of alpha plus beta. Okay, so if we just use this formula for this, 70 alpha is 75 degrees, beta is 15 degrees. So this will just be equal to 1/2 times cosine of 75 degrees minus 15 degrees, which is 60 degrees, and then plus cosine of 75 degrees plus 15 degrees, which is 90 degrees. And this turns out pretty nicely. Cosine of 90 is 0. Cosine of 60 is 1/2. So this answer is just 1/4. Okay, that wasn't so bad. Okay, the next one, cosine of 135 degrees times sine of 15 degrees. Well, when do we see cosine of an angle times sine of an angle? That occurs when we have sine of alpha plus beta. So sine of alpha plus beta is sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And then the other one, sine of alpha minus beta. This one is sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Well, there's more than one thing that we could do. It doesn't really matter. But let's use subtraction this time. So subtract. So when we subtract, we get sine of alpha plus beta minus sine of alpha minus beta. And then on the right-hand side, when we subtract, this term minus that goes away, and cosine of alpha times sine of beta minus cosine of alpha times sine of beta, we get 2 times cosine of alpha times sine of beta. And so our cosine of alpha times sine of beta, we're solving for this part, is 1/2 times sine of alpha plus beta minus sine of alpha minus beta. Okay, so if we use this formula, so alpha is 135 degrees, beta is 15, we get 1/2 times, whoops, I wrote the wrong thing, sorry. 1/2 of sine of 135 plus 15 is 150 degrees, and then minus sine of 135 minus 15 degrees is 120 degrees. And we have angles that we can evaluate. Sine of 150 degrees is 1/2. And sine of 120 degrees is the square root of 3/2. So the common denominator will be 4, and I'll have 1 minus the square root of 3 in the numerator. Okay, for the next one, we've already done some work that we could use for sine of an angle times sine of another angle. So if we look back up here, if we look at these two identities, my pen ran out of ink already. So on this one, we can get sine of an angle times sine of another angle if we subtract the second equation from the first one. So let's go ahead and subtract the bottom equation from the top equation. So we'll get cosine of alpha minus beta minus cosine of alpha plus beta equals 2 times sine of alpha times sine of beta. And so our sine of alpha times sine of beta will be equal to 1/2 times cosine of alpha minus beta minus cosine of alpha plus beta. Okay, so we'll use this formula. Alpha is 22.5 degrees and beta is 67.5. So I have to use something else besides red. So we get 1/2 times cosine of negative 45 degrees, and then minus cosine of 90 degrees. So cosine of 90 is 0. Cosine of negative 45 degrees is the same as cosine of 45 degrees. So this is 1/2 times the square root of 2 over 2, or the square root of 2 over 4. Okay, the next one, use sum to product formulas to evaluate. Well, I'm looking up here for something we can use. Okay, what we can use are these two equations. These two. So if I add these two equations, on the left-hand side, we'll get sine of alpha plus beta plus sine of alpha minus beta. And on the right-hand side, these will add up to 0. I'll just get 2 times sine of alpha times cosine of beta. Okay, so our formula, that's our formula. Sine of alpha plus beta plus sine of alpha minus beta equals 2 times sine of alpha times cosine of beta. So we have a little more work to do. 75 is our alpha plus beta, 75 degrees. And 15 degrees is our alpha minus beta. And when I add those together, the betas are eliminated, so I get 2 alpha equals 90 degrees. And so alpha is equal to 45. And if alpha is 45, we can see that beta is 30 degrees. Okay, so sine of alpha plus beta, that's sine of 75 degrees, that's equal to, well, we're multiplying 2 times sine of alpha, but alpha is 45 degrees, multiplied by cosine of beta, which is cosine of 30 degrees. And then we can evaluate this because sine of 45 is the square root of 2 over 2. Cosine of 30 is the square root of 3 over 2. And so this becomes the square root of 6 over 2. Okay, the next one. Okay, so now we have a cosine of 255 degrees plus cosine of 195. Well, I want to get to the other material, so let me see if I can point something out. Yeah, we can use this very top equation again. If you add those together, you can come up with a formula for a sum of 2 cosines. But let's move on to other material for now. So in section 9.5, this is the section where you solve equations, trigonometric equations, and we want to find our solutions on the interval from 0 to 2 pi. So on this one, cosine of 2x is equal to the square root of 3 over 2. And we know that there are 2 values where between 0 and 2 pi where cosine is equal to the square root of 3 over 2. So 2x equals pi over 6. And 2x equals, the other one is 11 pi over 6. Okay, but we're trying to find solutions for x, so if we divide both sides by 2, we get x equals pi over 12. And then x is equal to 11 pi over 12. Okay, but remember the period for y equals cosine of 2x is pi, so there's going to be 2 more solutions. Another solution will be pi plus pi over 12, which is 13 pi over 12. And then the 4th solution will be pi plus 11 pi over 12, which is 23 pi over 12. So this equation has 4 solutions in the interval from 0 to 2 pi. So they are pi over 12, 11 pi over 12, 13 pi over, sorry, that should be 13 pi over 12. And then 23 pi over 12. Okay, the next equation, cosine of x plus pi over 4 equals 1/2. The period of the related function is 2 pi. So we're expecting to find two solutions. We know that if x plus pi over 4 is equal to pi over 6, so one solution is, boy, I keep messing that up. This is pi over 3. Let me start over. Cosine of pi over 3 is 1/2. So if x plus pi over 3 is equal to pi over, x plus pi over 4 equals pi over 3, then cosine of that angle will be 1/2. So when we solve this for x, pi over 3 minus pi over 4 is 4 pi over 12 minus 3 pi over 12, or x equals pi over 12. Okay, that's one solution, but cosine is equal to 1/2 at another place, and that's when x plus pi over 4 is equal to 5 pi over 3 in the fourth quadrant. Okay, so when we solve this for x, we just subtract pi over 4 from both sides. So this will be 20 pi over 12 minus 3 pi over 12, which is 17 pi over 12. So we're okay because both of those numbers are between 0 and 2 pi. And there won't be more than two solutions between 0 and 2 pi, and we found them both. But this denominator should be 17 pi over 12. Okay, the next equation, secant of x squared minus 2 equals 0. Well, we can write this as secant of x squared equals 2. Then if you write the reciprocal of both, or I should say, this is equivalent to cosine of x squared equals 1/2. So a little bit more detail. Secant of x squared is 1 over cosine of x squared. 2 is 2 over 1. So if you just write the reciprocal, you get this equation. And then apply the square root property. Cosine of x equals positive or negative 1 over the square root of 2. But this is positive or negative square root of 2 over 2. So we know where cosine of x is equal to either positive square root of 2 over 2 or negative square root of 2 over 2. So this will have four solutions between 0 and 2 pi. X is equal to pi over 4 in the first quadrant. And then x will be equal to 3 pi over 4 in the second. And in the third quadrant, x is 5 pi over 4. And then finally, in the fourth quadrant, x is 7 pi over 4. Okay, here's another equation. 6 times cosine of x squared minus 7 times sine of x minus 1 equals 0. So on this one, I think we should replace cosine of x squared with 1 minus sine of x squared, and then we'll get an equation that's quadratic in form involving sine of x only. So 6 minus 6 times sine of x squared minus 7 times sine of x minus 1 equals 0. So make the left-hand side 0. We're going to add 6 times sine of x squared to both sides, add 7 times sine of x, and subtract 5. So we can factor this if I replace the middle term with plus 10 times sine of x minus 3 times sine of x. We can factor by grouping. Out of the first two terms, we can factor out 2 times sine of x. And then we're left with 3 times sine of x plus 5. And then out of the third and fourth terms, we'll factor out negative 1. So we get 3 times sine of x plus 5. And then finally, we get 3 times sine of x plus 5 times 2 times sine of x minus 1 equals 0. So we're only going to get solutions from one of the factors because when we set this one equal to 0, we'll get sine of x equals negative 5/3, but that cannot happen. That cannot happen because the range of sine is between negative 1 and positive 1. But the other factor, 2 times sine of x minus 1 equals 0, when we solve for sine of x, we get sine of x equals 1/2. Sine of x equals 1/2. And there are 2 solutions to this between 0 and 2 pi. One is pi over 6, and the other one is 5 pi over 6. Okay, in section 10.1, well, we won't have time to do everything. So let's just pick one of these side angle or law of sines problems. So if we have a triangle ABC where angle A is 43 degrees, angle B is 102. So my diagram won't really depict it accurately. That's okay, we're just using it for reference. So angle A is 43 degrees, angle B 102 degrees, and B is 42. So we don't know what side lowercase a is and C. We can figure out this angle. So that angle should add up to 35 degrees. Okay, so we can find A, lowercase a, if we write A divided by the sine of 43 degrees. And that's equal to 42 divided by the sine of 102 degrees. And then we can easily solve for A. A is 42 times sine of 43 degrees divided by sine of 102 degrees. We can also involve the other unknowns. C divided by sine of, for lowercase c, we get C equals 42 times the sine of 35 degrees divided by the sine of 102 degrees. Okay, the other examples, numbers 2 and 3, are same sort of process. So I'll leave those for you to work on. Find the area of triangle ABC, where angle A is 143 degrees, B is 20 inches, C is 16 inches. Okay, so the area under these circumstances, the formula is 1/2 B times C times cosine, or not cosine, sine of 143. So you can plug in those numbers. Okay, let's look at some law of cosine problems. Hey, so these aren't too bad. You might want to spend some time memorizing. So if we draw a triangle, A, B, and C, angle B is given, 67 degrees. A is given to be 14. C is given to be 30. And we don't know what lowercase b is, so the part of the law of cosines that we want here, b squared equals a squared plus c squared minus 2ac times the cosine of angle B. So A is given to be 14, so b squared equals 14 squared plus c squared, which is 30 squared, then minus 2 times 14 times 30 times the cosine of 67 degrees. Okay, so you can solve this for B. How would you find angle A? Okay, so if we do the arithmetic on that, we now know the value of B. So to find angle A, well, we'll use this formula, a squared equals b squared plus c squared minus 2bc times the cosine of A. Okay, because we know what A is. From above, we know what B is. C is also known. So we can determine what cosine of A is. So in symbols, we could write cosine of A is equal to a squared minus b squared minus c squared divided by negative 2bc. And so A is the inverse cosine of that number, a squared minus b squared minus c squared divided by negative 2bc. Okay, here's another example. Just apply the law of cosines to that. Couple more problems. Well, we have just a couple of minutes left. Convert from polar coordinates to rectangular coordinates. Those are the easiest ones. X is 3 times cosine of pi over 6, which is 3 times the square root of 3 over 2. And the y coordinate is 3 times sine of pi over 6, which is 3 times 1/2, or 3/2. Okay, let's work on one of these. We have less than a minute. Convert from rectangular coordinates to polar coordinates. Whoops. Okay. Yeah. Sorry. This point is in the 4th quadrant. Okay, we're out of time. Just real quickly, r squared is 4 times the square root of 2 squared plus 4 times the square root of 2 squared. And tangent beta is negative 4 times the square root of 2 over 4 times the square root of 2, which is negative 1. We saw an example very quite similar to this one earlier, but we're out of time now. We'll have our test 3 on Monday starting at about 11.